Hi Diksha Didi, good evening.
Okay.
So today we are going to be continuing with our assignment operators where we left yesterday. So let's just get started.
Okay.
Alright. So these operators are used to assign. So we reached till plus equals to operator. Let's just have a quick revision. Before going to assignment operators, let's just see what we just did in the previous class. We learned about bitwise operators that helped us do bit level operations. Then we learned about logical operators that were and, or, not, all of these operators that we have used in the basic course also. We have learned about relational operators that compares two values, and then we also learned about arithmetic operators, in which we learned about two operators, unary operators and binary operators. And binary operators were used to perform operations on two operands. Unary operators were used to perform operations on one operand. Alright, so let's just continue with our assignment operators. So these operators are used to assign values to a variable. The left side operand of the assignment operator is a variable, like a equals to 8, right? Then left side, sorry, int a equals to 8, you can say. So the left side int a is our variable, and the right side operand of the assignment operator is a value, like 8 is a value. A string that you give will be a value for the variable that will be on the left hand side of the operator. The value on the right side must be for of the same data type as the variable on the left side, otherwise the compiler will raise an error. So the value that you give on the right side needs to be the same data type as the variable on the left side, right? So if you have said int a is equals to a 8, right? So then the value 8 should be of an integer type only. So you said int a, so you have to give a value to a of integer type. If you say string x, you have to give the x variable a value of type string only, right? So data type should match on both left and right hand side of the operator. So here are the operators, assignment operators, different types of assignment operator. First we have the assignment operator itself, that is the equals to symbol, right? That assigns the value on the right to the variable on the left. So whatever value you have on the right, it will assign that to the variable on the left. For example, you have int a equals to 2, so int a is a variable on the left, 2 is the value on the right, and a's value is getting set to 2. And next we have add and assignment operator. So this is called an add and assignment operator. So this first adds the current value of the variable on the left to the value on the right, and then assigns the results to the variable on the left. So you have a equals to 2, b equals to 4. When you say a plus equals to b, what it will do, it will take a's value 2, it will add the value of b into it. So 2 plus 4, that will be 6, and then it will set the value of a as the new value. So a will now be 6, right? If we had a3, then it would have taken a's value to be 3, right? Then b equals to 4, and then it would have added 4 into the a's value, so it would have set a's value to 7 if a was 3. Next we have subtract and assignment operator, that is the minus equals to operator, right? So this first subtracts the value on the right from the current value of the variable on the left, and then assign the result to the variable on the left. So for example, we have a equals to 2, b equals to 4. When we say a minus equals to b, it will take the value of a, right? And then it will take the value of b, it will subtract the b value from a, right? So it will subtract 4 from 2, so the new value will be minus 2, and that will be saved in a, right? So over here the variable b is on the right hand side, your variable a is on the left hand side. So the value the operation will happen on the left hand side value only. So we have a on the left hand side, so from a, b's value will be subtracted and a's value be changed to the new value, right? So a minus equals to b, a's value will be affected, not b's value, right? So a minus equals to b will basically subtract 4 from 2 and set values the value of a to be minus 2. Next we have multiply and assignment operator. Star equals to, that first multiplies the current value of the variable on the left to the value on the right, and then assign the result to the variable on the left. So we have a equals to 2, b equals to 4. When we say a into equals to b, so it will take a's value, it will multiply it with the b's value, right? So 2 into 4, that will be 8, and a's value will be set to the new value. So a's value will now be set to 8. Next we have divide and assignment operator, that is the slash equals to. Slash represents basically division. So it first divides the current value of the variable on the left by the value on the right, and then assigns the result to the variable on the left. So for example, you have a equals to 4, b equals to 2. When you say a divided equals to b, right, then it will divide 4 by 2, right? So that will the result of 4 divided by 2 is 2, right? And the new value 2 will be set as a's value. So a division equals to b will change the value of a and set it to 2. So over here there's an example of each assignment operator. We'll just try to take evaluate the results ourselves, right? So we are going to, instead of looking at the output, we are just we'll just try to take out the result ourselves. So we have a equals to 6, b equals to 4. When we print a, we'll get 6. When we say a plus equals to b, it will add 4 to a, and then it will show. So it will be 10 over here. When we say a minus equals to b, it will subtract 4. So next we'll have 6, right? And when we say a multiply equals to b, right, so a multiplication equals to b, 6 into 4, 24, right? So we'll get a multiplication equals to b, we'll get 24 from it, and a division equals to b, we'll get 3 by 2, that is 1.5. I missed somewhere something. All right, so a equals to a, we are getting 6. We are saying a plus equals to b, so we are getting 10. A minus equals to b, we are getting 6. A multiplication equals to b is happening first, so that is also changing the value of a, and then a's value is getting divided. So a multiplication equals to b, 6 into 4, 24, that is going to be saved in as a's value, right? So a's value is not 6 anymore, it's 24, and then when we do 24 divided by 4, that gives us 6. All right, so over here I forgot that a's value was also changing. So a multiplication equals to b, over here 6 into 4 was happening 24, and that was 24 was the new value of a. And then when we were doing a division equals to b, then 24 divided by 4 was happening, that was giving 6 as a's new value. So are all of these assignment operators clear?
Yeah, they're clear.
All right, next we have the ternary operator, right? So this is a widely used, right? It's a very widely used operator, right? And it's a very important operator also. So this operator returns the value based on the condition. So this operator will return you a value based on the condition. So for example, you have expression 1, after the question mark you will have expression 2, and then after the colon you will have expression 3. So the ternary operator question mark determines the answer on the basis of the evaluation of expression 1. So according to expression 1, either expression 2 will get executed, or either expression 3 will get executed. If expression 1 evaluates to true, then expression 2 gets evaluated and is used as the answer for the expression. If expression 1 is false, then expression 3, that is after the colon symbol, gets evaluated and is used as the answer for the expression. So this operator takes 3 operands. So there are 3 operands: expression 1, expression 2, and expression 3. Therefore it is known as ternary operator. That's why it's known as ternary operator. So over here, if we give a truthy value, then it will execute expression 2. If there's a falsy value over here, then expression 3 will get executed. So we have int a equals to 3, b equals to 4, and int result we are checking a less than b, right? So if a is less than b, so 3 less than 4, right, that is false. So in b over here, this operator would have returned b if this was true. Now as this is a falsy value, it will go after the colon symbol and return a. Now A's value 3 is getting returned, right, and it is getting saved in the result variable. Now when we try to use the result variable, we'll get the greatest number is 3. So greatest number is 4. Over here we have a less than b. All right, I'm so sorry, we have a less than b. If we would have gotten, if we would have had a greater than b, then then we would have gotten 3 as the result. But we have a less than b, so 3 is less than 4, right? So 3 is less than 4, so this is a truthy statement only, so it will go after the question mark and return b, right? That is getting saved in result. So in the end it returns 4 only. Alright, so I got a bit confused there. I thought this was the greater than symbol, though it was the less than symbol. So I hope the ternary operator is clear. We did it before also in the basics course also.
Yeah, it's clear.
Alright. So there are some other common operators available in C++ besides the operators discussed above. Following is a list of these operators discussed in detail. So we have the size of operator, we have the comma operator, the arrow operator, then we have the cast operator, we have the dot operator, and star operator. Then we have the left this insertion and extraction operator, right? So we have the insertion and extraction operator, and then we are going to look at the operator precedence chart. So let's continue with the size of operator. So this unary operator, so it's a type of unary operator. So unary operators was a type of arithmetic operators. So over here, as we can see here, we saw some of the unary operators, plus plus and minus minus, and a size of is also a type of unary operator. So this unary operator is used to compute the size of its operand or variable. So size of char, this will return returns 1, as the memory char occupies 1 byte, right? So how many bytes a data type occupies, this size of method will tell us. So if we say size of char, char occupies 1 byte, so it returns 1. If we say size of integer occupies 4 bytes, so it will return us 4. If we say if we have an integer array containing 5 integers, right, and then we check size of that integer array, then what it will do, it will return us 20, as it is having 5 integers, each integer is 4 bytes, right? So 4 into 5 is 20. So if we would have given an integer array containing 5 integer elements to the size of method, that would give us 20. So this was the size of operator. Next we have the comma operator, right? So this binary operator, represented by the token, is used to evaluate its first operand and discards the result. So it then evaluates the second operand and returns this value and type. It is used to combine various expressions together. So over here what we have integer b, right, and then we have a plus 1 comma a minus 2 comma a plus 5. So what this will do, it is used to evaluate first operand and discards the result, right? So it first evaluates first operand and then it will discard the result. It then evaluates the second operand and returns this value, right? So it will return this value. So a plus 1 is 7, right? So a plus 1 is 7, right? And then a minus 2, what is a minus 2? A minus 2 is 4, and a plus it will only do over here a plus 1 is 7, then it will do a minus 2. So 7 minus 2, as a's value is changing, when we'll do 7 minus 2, right, that will be 5, and then when we'll do a plus 5, that will be 10, right? So we are going to look at the comma operator in detail. Right now we just need to understand that it is used to combine various expressions together. So right over here, a plus 1, a minus 2, a plus 5, we are combining these together, right, in one expression. We're going to see all its behavior, everything in detail in the unary operators chapter, right? So that will not be a problem, right? So if this is not clear, we are going to see in the unary operators chapter about this, so no problems in that. Next, we have the arrow operator. So this operator is used to access the variables of classes or structures. One use of this is it is used to access the variables of classes or structures. It is also used to access values from a pointer, right? So for example, if you have a pointer of an object, you have a pointer of an object and you want to access one of its properties values, then instead of using the normal dot notation, you will use the arrow operator that will allow you to take out the value from that object. So arrow operator is basically used to access variables of classes, structures, or you can use it to access values from pointer variables, right? So if you have a pointer to an object, right, and you have to take out the one of its properties values, then instead of using the dot notation, you can use the arrow notation. Next, we have the cast operator. So this unary operator is used to convert one data type into another. So this is also considered as an operator, where when a cast operator is basically when you try to change from one data type to another data type, then that is called the cast operator. So for example, we have float a is equals to 11.567 and we have integer c equals to int a, right? So this will cast this float variable to an integer, right, and this will return 11. So it will basically remove the decimal part and return the integer part, right? So this is used for casting. We could have also used to cast float to string, you could cast integer to string, right? So we can do many types of casting that we saw in the basic course also. Next, we have the dot operator. So this operator is used to access members of structure variables or class objects in C++. If we have structure variables, right? So if we have variables of a structure, so structure is basically used to define custom data types, right? So if we have a variable of a structure, right, or we have any classes objects, then if we want to access one of its values, one of its properties values, then we can use the dot operator. Next, we have the AND operator. So this is a pointer operator and is used to represent the memory address of an operand. So there are two uses of the AND operator. One is to create a reference variable, right? A reference variable is basically a variable that will point to the memory location of another variable, right? So either you can use AND operator to create a reference variable, or you could use the AND operator to take out the memory address of some value, right? So if a value is 10 saved in a variable a is saved in some memory address, so to take the memory address of a, you could say and a, and that will give you the memory location of a. Next, we have the star operator. So this is an indirection operator. So basically what this is used to create pointer variables, and also it is used to dereference pointers, right? So we have already seen about this. Here's an example also. We have int a equals to 6, and then we have int star b, right? So that is a pointer variable, right, that will save some memory location of another variable. Then we have int c. You're seeing b equals to and a will give us the memory location of a that is being saved in b, right? Then we are saying c equals to star b. Star b will dereference the variable over here. So we were saving the memory location of a in b in the b pointer variable. Now when we dereference it, we'll get the value of the a variable, that is 6, and that is going to be saved in c. When we print a, we are going to get 6. When we print b, we are going to get the memory location of a, and when we print c, we are going to get 6. Alright, so I hope this example is clear.
Yeah, Mr.
Alright, next we have the output operator, right? That is this two arrows, right? It prints the output value. So this is the output operator, right? And this is the input operator, right? So it gets the input value. So these are both extraction and insertion operators about which we have seen before also. And these are used with your streams, right? Those are C in, C out, and these are used with streams that we learned in the basics input output chapter, right? So in the output chapter we learned about the extraction and insertion operator, and also about the streams, different types of streams. Next, we have this operator precedence chart. So now this chart will tell, like for example, if you have many operators in one single statement or equation, then this chart will tell that which operator will get executed first. Alright, so first we have the parenthesis. So this has the most precedence, right? So every time when whenever there's your parenthesis, it will be given the most preference. After that, we have the array subscript operator, that is this, the brackets, right? So this is the array subscript operator, brackets, that will be given the precedence after parenthesis, right? Or these all of these have the same precedence, right? Parentheses, brackets, dot, arrow, and plus plus, and their associativity is left to right, meaning if you have parentheses and brackets both in the same line, right, then whichever operator will be the leftmost, that will get executed first, and then the rightmost operator will get executed. So over here, this parenthesis is the function call parenthesis. So when you have a function call, that will be given the most precedence if you don't have any of other or any of these operators in the same line, right? So if you have all of these operators in the same line, then it will evaluate all of these operators from left to right, right? And but if you have like brackets in and then you have star, for example, you have brackets and then you have star. So as if your brackets is on the right hand side and your star is on the left hand side, still brackets will be given more precedence, as brackets are more are on the upper part of the operator precedence chart. So here these all are given the most precedence, parentheses, then you have the brackets, then we have the dot, that is a member selection via object name, right? So for example, you have an object of class X, right? So you can, if you do say object dot first name, right? This is just an example, object dot first name, then dot will be given precedence, right? So it's on the topmost precedent, it's topmost in the precedence chart also. So the dot operator is also as given the most precedence, right? Similar, the same precedence is given to the member selection via pointer, right? To the arrow, you same precedence is given, that to the dot, same precedence, the dot and the arrow both have the same precedence. Then we have plus plus and minus minus. Note, there are two types of plus plus minus minus, one is postfix and one is prefix. So the postfix and postfix increment decrement is given more precedence than the prefix increment and decrement. So a plus plus will be given more precedence than plus plus a. Alright, next in the precedence chart we have all of these operators, right? So we have first the prefix, increment, decrement, and all of these will be evaluated right to left. So if you have all of these operators, for example, in the same line, then whichever operator will be rightmost among these, that will be executed first, and it will go on till the leftmost operator, right? So we have first the prefix, increment, and decrement. We also have the unary plus minus. Alright, so we are going to see that in the unary chapter, unary operators chapter. Next we have the not, logical negation, and bitwise complement. So both of these operators, bitwise complement and logical negation, right? So both of these also lie over here in the second part of the operator precedence chart. Next we have the cast operator, right, that converts value to temporary value of type. So basically the cast operator will basically change the type of the value. Then we have star dereference. So star, what this will do, it will dereference your pointer, right? So it is also used to create pointers. You can also use to dereference a memory location. So if you have a memory location using star, you can obtain the value that is stored in that memory location. Next we have AND, that is address of operand, right? So what this will do, and this will whatever operand you give with it, right, it will just take out its memory location. Next we have size of, that determines the size in bytes on this implementation. So basically size of, we have just seen, it's a unary operator that is used to take out the size of any your variable or your data type, right? So I hope this part is clear.
Yeah, it is.
All right. Next, in the operator precedence chart, we have the star, division, and the modulus operators. So you have the multiplication, division, and modulus operators, right? So, or if all of these are used on the same line, they will be evaluated from left to right. Next, we have addition subtraction on the operator precedence table. So it's basically like you have board mass in maths. We have this operator precedence table in C++. So when you have plus minus, that is used for addition subtraction. This is also evaluated from left to right. So if you have plus and minus in the same statement, then from whichever operator from the left occurs first will get executed first. Then we have the bitwise left shift and the right shift, right? So these also have the same precedence, right? And they have the same precedence on the operator precedence chart, right? And if you're using left shift first before right shift, right, so it's more to the left, right? So like from left to, if you have both left shift and right shift operators in the same statement, then whichever operator occurs first, like from the left, whichever operator comes first will get executed first. So if you are using the left shift operator first, and then to the right side you are using the right shift operator, or if you are using the right shift operator first and after that in the same statement you are using the left shift operator, so it will execute it from left to right. Next we have the less than or less than equals to, and greater than equals to. So these are on the sixth on the these are sixth on the operator precedence chart, right? So these are also their associativity is from left to right. Next on the operator precedence chart, we have the equals to and the not equals to operators, right? These are the relational or comparison operators, right? Is equals to and is not equals to, right? And they have the seventh precedence in the operator precedence table. Then we have on 8 we have the bitwise and, so this is not the address and, it is the bitwise and, right? So basically this we are going to study this in detail, and in the previous class also I explained in brief about bitwise and also, that if you have two bits, one two your bits that together, right? So if you have 0 1 1 0 and 0 1 0 1, right? So if two bits on the same position are 1, then only the bitwise and will return 1, else it will return 0. Then we have the XOR or the exclusive OR, right? So if you have 1 1 and 0 0, then it will return 0. If you have 0 1 or 1 0, it will return 1, right? So we are going to see all of that. Then we have inclusive OR, bitwise inclusive OR, right? That it checks if you have 1 1 0 1 or 1 0, then it will return 1, else it will return 0. Next we have the logical AND operator, right? That is used to like if it has two operands on the left and right, and if both the operands evaluate to true, then the logical AND operator will also give us true. Next on the operator precedence chart, we have the logical OR operator. So there are two operands on the left hand side and the right hand side. So if one of the operands evaluates to true, then logical OR will also return true. Next we have the ternary conditional operator, right? That is its associativity is from right to left, right? So the ternary operator we have just seen in today's class. We have just seen about the ternary operator, where there are three expressions, there are three operands. One is expression 1, right? And if that evaluates to true, then the expression after the question mark will get executed. If the expression 1 before the question mark evaluates to false, then the expression after the colon symbol will get executed. We just saw the ternary operator also. Then we have the equals to. All of these assignment operators have the same precedence. We have equals to, right? And all of these are executed from right to left. Associativity is from right to left. So you have assignment operator equals to, then plus equals to, minus equals to, multiplication equals to, division equals to, modulo equals to, bitwise and equals to. So we only did these many assignment operators. You also have bitwise and equals to. We also have exclusive or equals to. We have inclusive or equals to. We have left shift equals to and right shift equals to. So for all the bitwise operators also we have their assignment operators. Next, in the end, we have the comma expression separator, right? So last on the operator precedence table we have the comma operator. So the operators chapter is complete now, right? So we have learned a lot of things. We have learned about operator precedence, right? We have learned about the star operator, the left shift right shift operator, the and operator, dot operator, arrow operator, cast operator, comma operator, size of operator. Then we saw the types of operators. Before that we saw the ternary or conditional operators, right? We also saw assignment operators. We also saw bitwise operators. We also saw logical operators. We also saw relational operators. We also saw assignment operators, in which we had binary and unary operators, right? Sorry, arithmetic operators, in which we had unary and binary operators. Now we can move on to the arithmetic operators chapter, where they are explaining the arithmetic operators in detail. So I just want to confirm if everything is clear till now.
Yeah, it is.
Alright. So C++ arithmetic operators. So arithmetic operators in C++ are used to perform arithmetic or mathematical operations on the operands. For example, plus is used for addition, minus is used for subtraction, the star symbol is used for multiplication, etc. In simple terms, arithmetic operators are used to perform arithmetic operations on variables and data. So they follow the same relationship between an operator and an operand, right? So they have the same relationship between an operator and an operand. So there are two types of arithmetic operators: unary arithmetic operator and binary arithmetic operator. So first we have the binary arithmetic operator. So these operators operate or work with two operands. So these work with two operands, um, right? So you have one on the left of the operator and one on the right of the operator, right? So there are two operands. C++ provides 5 binary arithmetic operators for performing arithmetic functions. We have addition, subtraction, multiplication, division, and modulus, right? So addition adds two values, subtraction operator subtracts, the star operator is used for multiplication, the slash is used for division, and the remainder operator or the modulus operator is used to calculate the remainder after the division. So over here there's an example. We have int gfg1 and gfg2, right? We are setting gfg1 as 10, gfg2 as 3, right? Then what we are doing, we are saying gfg1 plus gfg2, so 10 plus 3 13, 10 minus 3, then we are doing, so that's 7, 10 into 3, that is 30, 10 divided by 3, so 10 divided by 3, what this will give us, this will give us 3, right? So it will say 3 3 6 9, right? And it won't give us the exact division, right? 10 divided by 3 will give us the floor division, right? So it is giving us 3, right? So because 3 into 3 is 9, right? And 1 is the remainder. So when we say gfg1 modulus gfg2, so this will give us the remainder basically after dividing GFG1 from GFG2, that is 1. So we have plus 13, in minus we had 7, in multiplication we had 30, in division we had 3, and in modulus we had 1. Next, we have the unary operators. So these operators operate or work with a single operand. We have decrement, that is postfix and prefix decrement, and we also have increment, that is postfix or prefix increment. So over here there's an example also. We have int x equals to 5, right? We are saying x plus plus, right? So when we are printing x plus plus, if you remember, we x plus plus will first return the original value of x, that is 5, and then increment it. So x plus plus will show over here, it will show 5, and after showing 5 it will set the value of x to be 6, right? Then when we say plus plus x, it will first increment the value of x, so from 6 it will change to 7, right? And then it will get shown, so a plus plus x, it will show 7. Then we have minus minus y minus minus y. Over here we have 10, right? So when we say y minus minus, it will show 10 only, right? And after showing 10 it will decrement the value of y, right? And when it's after showing 10 it will set the value of y to 9, right? And then when saying minus minus y, so it will first subtract the value, so from 9 it will be 8, and then it will show 8, right? So first we will be shown 5, then 7, then 10, and then 8. 5, 7, 10, and 8. So in plus plus x, the variable's value is first incremented, and in minus minus x, the variable's value is first decremented. In x plus plus or x minus minus, the variable's value is first assigned. First it's returned, and then it is increased. On x minus minus, first it's the value of the variable is returned, and then it is decremented, right? So very basic arithmetic operators we had here. Now we are going to see the unary operators. So unary operators are the operators that perform operations on a single operand to produce a new value. So we have types of unary operators. So types of unary operators are the unary minus, that we are going to see how it works, the increment plus plus, so this is a unary operator. Then we have the decrement minus minus, we have the not, that is also a unary operator. The address of operator is also a unary operator, and the size of method or operator is also a unary operator. So unary minus, the minus operator changes the sign of its argument. A positive number becomes negative and a negative number becomes positive. So we have a equals to 10, and when we say minus a, it will basically multiply a with minus 1, right? So it will just change, minus a will give us minus 10. If we had a's value minus 10, right, then minus a would have given us plus 10, right? So b equals to minus a will, if a's value is negative, it will change it to positive. If a's value is positive, it will change it to negative. So this is the use of unary minus. The unary minus is different from the subtraction operator, as subtraction operator requires two operands. Subtraction operator requires two operands. This unary minus is different as it only requires one operand. So below is the implementation also. So we have positive integer 100, then we have negative integer, that we are saying minus positive integer. So negative integer's value will be set to minus 100, right? And then when we print positive integer, it will show 100. When we print negative integer, it will show minus 100. So now the class is about to end in less than a minute. So I hope you liked today's class, and we'll meet in the next class.
Yeah, okay, thank you.
Thank you. Bye.